manually putting tags in each of different items in each of different aisles. Some will show by scanning the barcodes, while others will put a banner that indicate there is a flash sale that is currently happening in that specific aisle. Our store discount indicator aims to show the customers what aisle there will be discounted items. It will flash a light in 8 different aisles to attract customers that there is a discount that is happening in a specific aisle.
Hi, I'm Jeremy V. DeBorde, in charge of the simulations of our circuit. So, let's begin. So, this is our circuit. First, we have a main switch. It has a LED light which outputs a high value if you turn it on. Then, our switch 9 is connected to 8 switches, which we will convert later to a BCD value. So these switches have a pull-up resistor so that we can have a stable VCC to our inputs. Then after we invert our BCD values, we can get our desired values of the BCD. So after we invert the values, it will now be the input of our decoder. It will result to an 8-bit output, and each output has a 3-bit output. So let's simulate the outputs. So as you can see, if you click the switch 8, it will have the same result as the switch 1. But here, the value of our 3-bit output is 7. So, switch 2. Switch 5. That's just an example of how our circuit outputs the value.
Hi, my name is Jefferson Pons, and I will be discussing the ICs that we have used in our proto. So this is the 74148 IC that we used for the 8-line to 3-line priority encoder. We used 0, 1, 2, 3, 4, 5, 6, 7 for the inputs, and GS, A0, A1, and A2 for the outputs. While E0 is not connected, E1 is connected to the ground, and pin 8 is connected to the ground, while pin 16 is connected to VCC. So we used a 74138 IC for the decoder. For the inputs, we used pin 1's A, B, C, and G1, and we used for the enable is G2A and G2B. For the output, we used Y01, Y1, Y2, Y3, Y4, Y5, Y6, Y7, and we connected the pin 8 to the ground and pin 16 to VCC. So we used a 74138 IC for the decoder. For the inputs, we used pin 1's A, B, C, and G1, and we used for the enable is G2A and G2B. For the output, we used Y01, Y1, Y2, Y3, Y4, Y5, Y6, Y7, and we connected the pin 8 to the ground and pin 16 to VCC. So we used a 7408 IC for the 2-input AND gates. We used pins 1, 2, 4, 5, 10, 9, 13, and 12 for the inputs, and 3, 6, 8, and 11 for the outputs. We connected pin 7 to the ground and pin 14 to the VCC. We used a 7476 IC for the JK flip-flops. It has a clear, preset, and complementary outputs. For the J inputs, we used pins 4 and 9. For the K inputs, we used pins 12 and 16. For the first output Q1 is we used 15 and pin 11. For the complementary of the output, we used pin 14 and pin 10. For the clear, we used pin 3 and pin 8. For the clock, we used pin 1 and pin 6. For the preset, we used pin 2 and pin 7 while connecting pin 13 to the ground and pin 5 to VCC.
These are our 8 switches from 1 through 8, and these switches are connected to a pull-up resistor, which is then connected to this encoder right here called 74148 IC. The outputs of this IC are connected to this 7404 IC, which contains the NOT gates, and the outputs of this NOT gates are connected to this decoder called 74138 IC. The 74138 ICs are the ones connected to the LEDs, which represents the 3-bit outputs the store owner wanted for each aisles. These 3 LEDs right here, which are different in color, represents the 0 in binary, and this is 1, 2, 3, 4, 5, 6, and 7. All this represents the 8 aisles. For it to be a sequential circuit, a counter was added. In here, these 2 ICs, they are called the 747 ICs or JK flip-flops. The outputs of this are then connected to these LEDs, which counts from 0 to 7 every time a switch is turned on. This push button represents the reset button. Now, all this circuit wouldn't work without this toggle switch right here. This toggle switch represents our main switch or our breaker, and this whole circuit only works when this is on.
Zero, 1, 2, 3, 4, 5, 6, 7. Good day everyone, I'm Ato Matel, and today I will discuss to you the scope and the limitation of this project. So for the scope, first it can indicate the discounted aisle from the store. So next is that it can discount and count at the same time. And last, it can reset the counter. So for the limitation, it cannot input 2 values at the same time because we use the priority encoder to get the desired value. And the next is that it is in 3-bit binary and it cannot count more than 7.